In today's talk, I'm going to be talking to you about artificial intelligence. I'm going to look at what artificial intelligence actually is, some examples of how we already use it today. Then I'm going to talk to you about some of the kind of key terms in artificial intelligence. And then lastly, I'm going to talk to you about two kind of big ideas or concepts. So to start us off, what is artificial intelligence? I think when we first maybe think of artificial intelligence or AI, we might think about something like this, a kind of killer robots who are gonna destroy humankind. But actually, the more kind of realistic portrayal of what artificial intelligence actually is, at least now, and probably for the foreseeable future, this is a way off it. There's a good chance that's never going to happen. But if we think about instead this, so a brain kind of shape, but a microchip. So artificial intelligence is all about giving kind of computers brains, or we might think of an area of computer science that focuses on simulating human intelligence in computers. So trying to make computers kind of think like we do, or be able to do the kind of highly intelligent thinking that we do about certain things. So first of all, I would like you to have a think about any examples of artificial intelligence that you come across or interact with in your kind of everyday life. So I'm going to kind of give you a few seconds to think about that now, but if you'd like more time, feel free to pause the video here. Okay, so moving on, I thought of a few examples of AI that you probably have come across and you may well interact with on kind of maybe a daily basis even. So first of all, voice-activated assistants. So for example, Siri, Alexa or Google Home. And the way that these kind of voice-activated assistants work is that you will kind of say a command or ask a question, and they will be able to recognise your voice, but also the words that you're saying, and do something. So it might be set a timer, it might be what is the weather in London today, it might be you know, what if you're, I don't know, if you're cooking, what is the temperature in Fahrenheit versus Celsius, anything like that, and they're able to kind of respond to those questions and commands and kind of do what you've asked them. But I'm sure you've also come across kind of limitations of this. So there'll be times when, you know, Siri will say, I don't understand, or you'll kind of get trapped in this back and forth where you ask something and they respond with not quite the right thing, but you can't get them to do the thing you're quite after. Kind of similar to that is the online chat function on websites. So for example, if you're doing online shopping, sometimes you'll see in the kind of bottom right hand corner of your screen there'll be a kind of chat now box, or you know, something will pop up and say hello and you can type a response. Often this is not a person or people sitting in, you know, a computer centre somewhere responding to you. This is a chatbot. So essentially what's happened is a chatbot has been trained to understand lots of kind of phrases that shoppers might have. So I don't know, do you have this in a size 12? Can you deliver by midday tomorrow? And the chatbot will respond with kind of set phrases. But again, like these voice-activated assistants, there might be limits to it. So, you know, you'll have a question you can't answer, and either you'll just get stuck in this kind of back and forth, or you'll be directed to actually speak to a human on a chat system, or phone a person who works for the company. And lastly, online recommendations, so on things like Netflix or Amazon. So for example, once you finish watching something on Netflix, Netflix will respond by kind of recommending things that it thinks you might like. So this might be, you know, you've watched a film with an actor in it, and it'll recommend another film with that actor in. But these recommendations are smart, so they're not set the first time they kind of come up with them. They keep on changing based on your behaviour. So they might recommend a horror film to you, but if you don't watch that horror film and the next kind of 5 things you watch are not at all in the horror genre, then the kind of system there would know, okay, well, this person doesn't seem to like horror, so we'll stop recommending that and start recommending things that are more in a genre that we know that they listen to or that they watch, sorry. So those are a few examples of artificial intelligence in your kind of everyday life, things you probably, even if you've not personally kind of experienced, you're probably quite aware of already. So when we're thinking about artificial intelligence, essentially artificial intelligence is powered by algorithms, and this is kind of how a lot of computing works. And this is basically a kind of series of sort of decisions or questions that get asked to get the right kind of output from an input. So if something, then do this. So we can think of it like a recipe. You know, if you were making a recipe, you might say, if you have added eggs, then whisk in flour. But if you don't have eggs, then use an alternative. And you can see this decision tree that someone has made for playing tennis. So looking at the outlooks, that means the weather. If it's rainy and it's windy, it says if there's a weak wind, you know, continue playing. I'd probably say no because it's raining, but you know, different decision trees, and here again different decisions that can be made based on the input that comes there. So if sunny and humid, no, don't play, or if sunny and normally humid, yes, do play. Now, there's a really good BBC bite-sized guide to algorithms, so I'm not going to say any more on algorithms because I think it would be more useful and they're better explained on this BBC bite-sized guide, so I'd really recommend looking into that. Algorithms are really, really important for computing and also for lots and lots of different mathematical functions as well. So now I'm going to talk to you about some of the key terms in artificial intelligence. So first of all, natural language processing. So computers recognising or responding to language. So you might think here about something like Google Translate, which obviously can take something in any language and translate it into another language, but as I'm sure you've kind of experienced with that, sometimes it'll be slightly awkward. The translation isn't perfect, or it sort of does take the literal meaning but not kind of quite right in the phrasing there. Now, natural language processing is all about taking the kind of building blocks of language, so you know, the nouns, the adjectives, the adverbs, the meanings, the way a sentence is structured, and teaching computers how to use that and how to do that. So a lot of that comes down to teaching computers how to write. So an example of this is that now some websites will have pieces of journalism that are entirely written by computers. Often this will be for things that are fairly kind of formulaic and predictable. So a good example might be a piece on the weather. You know, if you give an algorithm the information on what the weather is and is probably going to be for the next 3 days, they can kind of quite easily order that and put it in sentences. There's also things like sports reporting. Obviously, if you're just kind of saying the match was 2-1 at half time, but by full time the away team were up 3-2, that's something that easily a computer can report. And even if you wanted to put in a few more subjective terms or more colourful phrasing, you know, there's kind of set phrases that lots of sports journalists use. You might say, the opposition were utterly destroyed by the attacking team, or you might say it was a shambles in midfield, and you could kind of give a computer these set phrases and again kind of when to use them, if this then that, and again a computer could write that. You even have kind of instances now of computers writing poetry and stories and lots of different things there. So that's natural language processing. Next is machine learning, and in order to explain to you what machine learning is, I'm going to give an example of developing an app, and this would be an app that you can point at something and it can tell you if it's a cat or not. So first of all, I would like you to imagine if you were explaining what a cat was to someone who had never seen a cat before, how would you explain it? So if you'd like, here you could pause the video and maybe write down 5 things that make a cat a cat. So if you want to pause here, you can do and write those down. Okay, so think of 5 things that make a cat a cat. You might say, it's fluffy, it's got 4 legs, it has a tail, it often is kept as a pet, it's not too big. But then there are lots of other things that might fit some or all of that description. So, a cardigan can be fluffy. Horses have 4 legs and a tail. We keep rabbits as pets. They're small, they're fluffy, they have 4 legs, they have a little tail. So it becomes quite hard to kind of say exactly what a cat is. So the way that machine learning works is that you give machines a big data set of the thing you're trying to get them to recognise or be able to distinguish, and you don't tell them what to look for. You might give them some pointers to say this is a cat or this isn't a cat, but you allow the machine to work out what makes a cat a cat. So we give it some images of cats, some more. So the machine might start to work out things like, okay, 2 eyes, a nose, fluffy, lots of different colours, and then you'd also need to put in some other images. So for example, this dog sort of fits a lot of those, but maybe the ears are a bit more curvy, whereas cat's ears are more pointed. You might give an image of a toy cat, work out why that doesn't fit the picture of a kind of live cat. So machine learning is about training a computer to spot patterns. What is a pattern between all of these images of cats that these 2 don't fall into? And this can be really powerful. So machine learning to analyse millions of data points to work out patterns in things like diagnosing diseases, for example. And that's not something necessarily that one human or even a group of humans could do, or could definitely do as quickly, because machines can just handle so much more data. But obviously there could be flaws in it. For example, if we only trained this app on images of sort of grey cats, like the one in the kind of right-hand picture, then the machine would get very good at identifying grey cats, but wouldn't be able to identify cats of any other colour. So you have to be careful when you're thinking about your data sets. Now, this is the kind of spectrum of AI. Weak or narrow AI going to broad or strong AI. So weak or narrow AI is AI that has a specific function and does that function but can't do other things. So for example, AI in your voice activated assistant, it can do the things that it's been trained to do, but it can't do something else. It can't suddenly write you a poem, it can't print something, it can't do lots of other tasks. So weak or narrow AI might say AI that can do small discrete tasks that it's been trained to do, whereas broad or strong AI is this concept of AI that's much more like a human brain. So a human brain can do, loads and loads of different kinds of things, and it can also learn how to do totally different things that's been done before. You could be someone who's really sporty, but that doesn't mean you couldn't also learn to be someone who was really good at science. Whereas if you've got a machine that's been trained to do lots of sports stuff, it might be harder to train it away from that kind of narrow focus to also focus on science. And that's the kind of possible aim of some AI research, not all, but that's the aim of making a really powerful, really strong AI would need to be an AI that was really flexible and could do lots and lots of different things. So I'm now going to talk to you about 2 kind of big ideas within artificial intelligence. So first of all, the human in the loop. And the idea with the human in the loop is that some proponents of AI say that AI could do wonderful things, but it has to have a person also making decisions. It can't be that we let AI just look at a situation and say, okay, the most efficient decision is this, and do it. We need a human in the loop making that decision. So a kind of example of where this might be relevant is driverless cars. We think about, driverless cars could, do loads of really good things, but what if that car got into an accident, or what if that car, drove into a person to avoid colliding into something else. Lots of sort of big ethical questions there. And the idea is there that if it's truly driverless, if there's not someone controlling it, then there's no human in the loop. So maybe what should happen is, you know, the car should propose things, so I'm going to go this route, but then the human in the loop is able to say yes or no and have the final kind of responsibility and accountability for that decision. Now, the last thing that I'm going to be talking to you about today is the Turing Test. So the Turing Test was created by Alan Turing, and essentially the Turing Test is as follows. If an AI can convince a person that it is a human and not AI, then it has passed the Turing Test, and it is kind of as powerful as AI can be. And the way that this test was originally formulated is that you would have someone acting as judge, and they'd be communicating with two kind of things. One would be a person and one would be a computer. And if the judge was unable to decide which was which, who was the person, and, you know, which person answering or not person answering was the AI, then the AI has passed the test. Now, the criticism of this is that, you know, maybe it would be easy for the AI to pass the test. For example, if it was closed questions, if it was just yes or no answers, then actually there's kind of a 50% chance with each question that the AI answers the right answer to convince the person. And even if it's kind of following that decision tree of yes and no, then yes, statistically at some point, presumably, an AI would answer the right chain of answers to convince the judge that it was human. And the other question is, of course, you know, well, it might be convincing that it is human, but then when the person saw it, they'd know it was not human. So is there something kind of visually that we need to go on, kind of, as this image suggests? Do we need to have AI that also looks human before we truly believe it is human? So hopefully that has been a useful introduction to artificial intelligence. Thank you for listening and watching.